Okay, let's try this problem. What is the Kb for a 1.0 molar weak base whose pH is 11.60? Okay, we know we have a weak base. So the plan of attack, if you have a weak base, put the base in water, ice it with a Kb. Now, they didn't give me an equation for the base, so a formula. So when I didn't have a formula for a weak acid, I called it H with A, acid, all the rest. For my weak base, I'm just going to use B or B minus. I prefer B minus. My base, B minus, I'm going to take that base, put it in water. My base is going to weakly accept protons. That gives me the conjugate acid HB, and there's the hydroxide that I'm looking for when I remove an H plus here. So I put my base in water. I'm going to go ahead and ice it. When I ice it, I know I'm starting off with a 1.0 molar solution. There is no conjugate acid yet, and there is no hydroxide yet. So we've got our base in water here. Now this is going to go in the forward direction. We're going to take away X, we're going to add X, we're going to add X. At equilibrium, the OH minus is X, the conjugate acid is X, and I don't know if I can drop this here because I don't have the equilibrium value. I can't say 100 times K is less than my start. So I have to leave that as 1.0 minus X. I know that the Kb will be the products over the reactants. In the end, it's going to be X squared all over 1.0 minus X. But I don't know what X is, and I don't know what Kb is. So there must be some other information in the problem. That is the pH. I'm going to remove this to give myself a little more room. We know that the pH of this solution is 11.60. pHs can be used to help us determine what the H3O plus hydronium concentration is, or what the hydroxide concentration is. If I want the hydroxide, which is my X, I don't really want to talk about pH. pH doesn't help me with OH, but POH will. I can find the POH by taking 14 minus that pH value. The POH is 14 minus 11.60. That gives me a POH of 2.40. Okay, now how does that help? We can use the POH to find our OH. So we're going to say the POH is equal to the negative log of the OH minus concentration. I'm going to take my negative over. Negative POH is positive log of OH minus, and I'm going to inverse log that. So the OH minus is 10 to the negative POH. OH minus is 10 to the negative 2.40. And if we go ahead and solve for the OH minus, we get 0.0040 molar for my OH concentration. I can now take that and plug that back in to my ice table. The OH minus is 0.0040. The HB, 0.0040. And when I take 1.0 minus this tiny number and I keep it to one decimal place, it's basically unchanged, not significantly changed. It stays 1 molar. Those are the values I'm going to plug in for my Kb. Kb equals on top 0.0040, and that is going to be multiplied by itself. So we're going to go ahead and square that. and that is over 1.0. So if we take 0.0040 and square it, the KB ends up being 1.6 times 10 to the minus 5. I hope that helps. Take care.